Yeah. Good morning, my dear students. Today we will discuss about the sets chapter. Okay. In our 11th class NCERT textbook sets chapter. Sets. Okay. What is set? Example definition. What is set? In 8th standard. The set definition in our learning. Okay, collection of object is called set. Understood? In here also set definition is there. What is the set definition? Collection of well-defined objects is called the set. Understood? What is the set definition? Collection of well-defined object is called the set. Understood? This is the definition of set. Then a set can be denoted by the capital letters. A set can be denoted by the capital letters and defined by the small letters small letters like alphabets, numbers, special symbols, etc. Understood? This is all about the set definition. Collection of well-defined object is called the set, and a set can be denoted by the capital letters and defined by the small letters like alphabets or number, special symbol, etc. See, example of set. Example of set is A is equals to 1, 2, 3, 4, and so on, infinity. Understood? And one more example. B is equals to A, E, I, O, U. Understood? This is the one more different example of the set. Understood? This is called a set. Collection of well-defined objects is called a set. And a set can be denoted by the capital letters and defined by the small letters, numbers, special symbols, etc. Understood? Then a set can be represented by the two types. Understood? Next, representation of the set. A set can be represented by the two types. Okay? Representation of the set. Representation of set. Understood? A set can be represented by the two types. Okay? One is the roster form. Second one is the set builder form. Understood? This is the representation of the set. A set can be represented by the two types. One is the roster form. Second one is the set builder form. See, what is roster form? What is set builder form? We will discuss it. Okay, first one was roster form. Roster form. What is roster form of? Converting the, see, converting the mathematical statements into the mathematical statements or conditions. Statements or conditions. Conditions. Converting the mathematical statements or conditions into the elementary form. Elementary form or numbers form or alphabetical form. Alphabetical form by separating the comma. Okay, comma and enclosed by the flower brackets. Enclosed by the flower brackets. Understood? This is called the enclosed by the flower bracket. Is called the roster form. Understood? This is called the roster form, converting the mathematical statements or mathematical conditions into the elementary form or numbers form or alphabetical form by separating the comma. Understood? Separating the comma and enclosed by the flower brackets, like this type of brackets. Flower brackets is called the roster form. Example of roster form. See, example of roster form. A is equals to x such that x is a natural number. Understood? This is the mathematical condition. Understood? This mathematical condition can be converted into elementary form. Means capital A is equals to 1, 2, 3, 4, 5, and so on. Understood? This type to this type. This is the mathematical condition. Here x is a natural number. Here x is a natural number is the one mathematical condition. This mathematical condition form can be converted into elementary form or numbers form or alphabetical form by separating the commas. Understood? By separating the commas and enclosed by the flower brackets. Enclosed by the flower bracket is called the roster form. Understood? The set can be segregated by two types. One is the roster form and second one is the set builder form. Understood? What is roster form? Converting the mathematical statements into the elementary form, number form or alphabetical form by separating the comma and enclosed by the flower bracket is called the roster form. Understood? Example like that. Then we will discuss the second one. What is second one? Set builder form. Understood? This is opposite of roster form. Understood? Set builder form. Converting the elementary form or numbers form or alphabetical form into the mathematical conditions form by eliminating the comma and enclosed by the flower brackets. Flower brackets. Now, sure, this is called the set builder form. What is set builder form? Converting the elementary form or numbers form or alphabetical form into the mathematical conditions or statements form by eliminating that comma. So, eliminating the comma and enclosed by the brackets. See example. Now, sure, example. Same thing, right? X is equals to 1, 2, 3, 4, 5, 6, and so on up to infinity. This is what Prosser form. Understood? This is the Prosser form or elementary form. This form can be converted into x such that x is a what a natural number. Understood? X is a natural number. Understood? This is called the representation of the set. A set can be represented by the two ways. One is the Prosser form and second one is the set builder form. Prosser form, simply we can say that converting the mathematical conditions into elementary form. Example, x such that x is a natural number. This is the mathematical conditions form to elementary form. And set builder form. Set builder form, simply we can say that they converting the elementary form into the mathematical conditions or statements. One is called the set builder form. Understood? What is set means? The set is a collection of well-defined objects. Understood? The set can be represented by the two ways. Now we will go for the types of sets. Understood? We will go for the types of sets. Types of set. Understood? There are different types of set. There are okay. One is called the what are one you know very well. What is one empty set? Empty set of wide set. Second one what? Second one finite set. Understood? Third one infinite set. Third one subset. And third one fourth one. Okay. Fifth one equal set. Fifth one. Then sixth one universal set. Understood? This is called the types of sets. Understood? Types of sets. What is types of sets? Empty set or wide set, finite set, infinite set, subset, equal set, universal set. Okay. One by one we will discuss here. See. First one, what is the empty set? The name itself is the empty, means nothing. There is no element. Understood? What is empty set? If a set is said to be empty set. Understood? If a set is said to be empty set, means it does not does not having any elements. It does not having the any elements. Understood? If a set is said to be empty set, it does not having the any elements. Understood? Example: A equals to like no elements. Understood? Then B is equals to 5. Understood? This is called the example of the empty set. What is empty set? A set is said to be empty set. It does not having any elements is called empty set. Understood? Then next go for the finite set. Next go for the finite set. Next go for the finite set. Second one. Finite set. Understood? Second one, finite set. What is finite set? Means if a set is said to be finite set, it contains finite number of elements. Understood? This is called the finite set. If a set is said to be a finite set, it contains the finite number of elements or countable number of elements. Understood? Finite number of elements or countable number of elements. Countable number of elements. Understood? Example. A is equals to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Understood? This is the finite number. This is what the roster form. Then we will write the set builder form of same set. X such that X is a natural number. Understood? X is a natural number. X is a natural number less than or equals to n. Understood? This is called the set builder form. Understood? This is called the roster form. This is called the set builder form. Some example of finite set means what will be the number of students in a class, which is a countable. Understood? Number of two-wheelers are there in India. We will count is there. Some quantity number is there. Understood? This is called the finite set definition. If a set is said to be a finite set, it contains the finite number of elements. Or countable number of elements contains. Understood? The example of this is 1, 2, 3, 10. X is such that X is a natural number less than or equals to 10. Understood? A few more examples you will get. X equals, you can write the even numbers less than 10. Understood? Odd numbers less than 10. Like this type of conditions is called the what? Set builder form. Which type of condition is called the roster form. Understood? Then third type we will discuss here. That is third one. Infinite set. Infinite set. Understood? First one what the empty, second one infinite, third one is the infinite. Infinite easily you can say. The set which is not finite is called the infinite. Understood? The set which is not finite set is called the infinite. We will we will give the definition like this. Say, what is finite set means? A set is said to be infinite set. A set is said to be infinite means it contains infinitely infinite number of elements, infinite number of elements is are uncountable elements. Uncountable elements is called the infinite set. Infinite set. Understood? What is infinite set? If a set is said to be infinite, it contains the infinite number of elements or uncountable elements. Is called the example. Count the number of stars. We don't know. Understood? Count the number of stars. Number of infinitely number. How many largest number in mathematics? We don't know. Understood? This is called infinite number. Understood? Infinite set. Example of this means A is equals to 1, 2, 3, 4 up to and so on infinite. We don't know. Understood? Then this is what a Prosser form. We will write it singular form. Okay, x such that x is a natural number. Understood? X is a natural number. We don't know. Understood? Here restriction is there. Here no restriction. Understood? This is called the infinite set. A set is said to be infinite set. It contains the infinite number of elements. It is called the infinite set. Understood? Then we will go for the fourth type. What is fourth type? Subset. What is fourth type of subset? Fourth type, understood? Subset. Subset. If letter A and B be non-empty sets. Let A and B be the two non-empty sets. If capital A is said to be subset of B, it means each and every element, each and every element of A has a element of B. Understood? What is subset? If A and B are two non-empty sets, if A is said to be a subset of B, means each and every element of A. Understood? Each and every element of A has an element of B. Understood? If A is, for example, A is said to be a subset of B, means each and every element of A has the element of B. Say example, if I take an example of A is equals to, I am taking even numbers 2, 4, 6, 8, 10. Up to 10 I am taking. B set I am taking 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Up to 10 I am taking. Now if you are observe, if A is said to be a subset of means each and every element. If you clearly observe 2, 4, 6 is each and every element. Understood? If any one element is missing also, which is not a subset. Understood? Now if you are observe here 2 present, 4 present, 6 present, 8 present, 10 also present. Understood? Now each and every element of A is an element of A. Then clearly A is subset to B. Understood? A is subset to B. A is subset to B. Understood? This is called the subset. Let A and B be the two non-empty sets. Let A is said to be subset of B. Means each and every element of A element of B. Understood? Like this example. I hope we will get idea about what is subset. Then we will go for the equal set. What is equal set? Fifth one. Fifth one. Okay. Equal set. What is the equal set means? Let's consider the let A and B be two non-empty sets. Let A and B be the two non-empty sets. Now, sure, if A is said to be equal set to B means number of elements. Okay, number of elements equals to number of elements in A equals to number of elements in B, and the order of the elements is not mandatory. Understood? Means order, preceding order of elements, preceding order of elements is not mandatory. Understood? Preceding order of elements is not mandatory. See example. For example, A is equals to 1, 2, 3, 4. Understood? A, then B is equals to, here last point was the order. Preceding order is not mandatory. Means 2, 1, 4, 3. Understood? Here number of elements were 4. Preceding order is not mandatory. That's why here A equals to B. Understood? This is the equal set. This is the subset. Subset means each and every element of A has the element of B. Here number of elements equals to number of elements. Understood? Now every equal set is a subset. Understood? Every equal set is a subset. Understood? This is the one key point if you are observing here. Then last one, sixth, we will go for the universal set. Last one for the sixth one. Universal. Understood? Universal set. What is universal set? The universal set. And universal not and universal set is denoted by capital U. Understood? The universal set is denoted by capital U and defined as the U is equals to, it contains the set of all subsets. Contains the set of all subsets is called the universal set. Understood? Universal set is denoted by the capital U, defined as the capital U is equal to set of all subsets. For example, I am taking. Understood? U 1, 2, 3, 4, 5, 6 and so on infinity. Understood? Now, capital A is equals to, I am considering even numbers 2, 4, 6, 8, and so on infinity. Understood? Capital B I am taking set of odd numbers. Understood? 3, 5, 7, and so on infinity. Understood? Now, here if you are observing that A is subset to U. Understood? B is subset to U. Understood? Now, capital U is it contains all the subset. It contains all the subset. That's why it is a universal set. Understood? Now, you will get clarity about the what is set, representation of the sets and types of sets. Understood? This is called the set types of sets. Understood? Then we will go for the next concept, operational sets. Understood? What is the next concept? Operational sets. Understood? What is the next concept? Operational sets. See, before starting the operational sets, we will discuss the one basic concept. Understood? What is the next concept? Operational sets. What is the next concept? Operation on sets. Okay. See, before starting the operation on sets, we will discuss some basic concept. What is the Venn diagram? Venn diagram. Okay, Venn diagram. What is Venn diagram? Is the relationship. What is Venn diagram? Is the relationship between the relationships between the operational sets. What is operational sets? We will discuss. Okay, relationship between the operation on sets. Okay, the relationship between the operational sets represented, or the relationship between the operational sets represented pictorially. Understood? What is the Venn diagram? The relationship between the operational sets represented by the diagrammatically or pictorially. Understood? Diagrammatically is called the Venn diagram. Understood? The relationship between the operational sets represented by the diagrammatically is called the Venn diagram. Understood? Here, that universal set can be represented by the universal set is represented by this rectangular bracket. Understood? Universal set can be represented by this rectangular brackets and all subsets. All subsets are represented by the circles. Represented by the circles. Very important concept. Understood? Venn diagram of operational sets. See, before starting the operational sets, we will discuss some basic concept. Venn diagram. What is Venn diagram? Is the relationship between the operational sets or relationship between the sets. Understood? Operational sets represented by the diagrammatically is called the Venn diagram. Diagrammatically or pictorially, understood? Pictorially is called like this. Then the universal set in a Venn diagram, the The universal set can be represented with the rectangle. Understood? Rectangular shape. And the remaining all subsets are represented with the circle. This is called about the Venn diagram. Then we will go for the operation on sets. Understood? Then we will go for the operation on sets. See, why we will what are the operation on sets? Why we will go for why we need to study this topic means see my dear students in our 10th up to 10th standard we have studied the operation on any two numbers like addition of two numbers, understood, subtraction of two numbers, understood, or three numbers, understood, up to 10 numbers, up to 100 numbers without it, understood, multiplication of two numbers, three numbers, we have done, understood. So, okay, some finite number we will do in a operation, understood, like 100, 1000, we will do, it will take time, understood. But operation on sets means you need to do operation on n numbers, understood. If you taking time, okay, I need to do 1 plus 2 plus 3 plus so on plus 1000 we need to do, understood. If you are want to do up to 1000 means it will take time, understood. So we need to overcome that situation. Our mathematicians are introduced the operation on sets, understood. Operation on sets. Operation on sets are segregated by the 4 types. Okay, operation on sets can be done by 4 types. 4 types. One is what union operator. Okay, union operation. Union operation. Then second one, intersection operation. Intersection operation. Okay. Then third one, difference. Understood. Then fourth one, complement. Understood. This is called the operation on sets. Okay. Union of operation or union of two sets. Intersection of two sets. Difference of two sets. Complement of two sets. Understood. See one by one we will discuss. First one what? Union. Union of or union operation. Okay. See, the union operation can be denoted by the capital U. And union operation is denoted by capital U. Understood? Now, define it as the let A and B be two non-empty sets. Empty sets. Understood? Let A and B be the two non-empty sets. The union of two sets. And union of two sets is denoted by A union B. The union of two sets is denoted by A union B, defined as the A union B. A union B equals to X belongs to A or X belongs to B. Understood? X belongs to A or X belongs to B. Very, very important. This is called union operation. Union operator. Let A and B be the two non-empty sets, and union of two sets is denoted by the A union B, and defined as the A union B equals to x belongs to A or x belongs to B. Understood? This is called the union operation. Now, example of union operation can be example. Understood? Example of union operator. See, let us take a example. A is equals to 1, 2, 3, 4, 5. Understood? Then B you can take a, okay, B you can take a 6, 7, 8, 9, 10. Understood? Now A union B can be defined as the A union B is equals to, what is the definition? X belongs to A or X belongs to B. Both you need to write and any repetition element you can take as a only ones. Understood? Now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is called the union operation. Understood? This is called the union operator. And the diagrammatically, understood? Venn diagram of union operator can be, see, this is called the universal set. This is called the universal set. Understood? Previously we are discussed. Now this is called the A. This is called the A. Now this is called the B. Understood? This is called the B. Now A union B. A union B there are. So means all the elements. See what is the shaded reason? If you observe. Understood? This is a total. This is what? A union B. Understood? This is the diagrammatically union can be represented as the like this. Understood? What is union operator? An union operator is denoted by U. Let A and B be the two non-empty sets. The union of two sets is denoted by A union B, defined as the A union B is equals to X belongs to A or X belongs to B. Understood? Then A, B. This is the example. Then properties of union operators. Properties of union operation. Understood? There are a few properties are there. One by one. See, first property, A union B is equals to B union A. This is the commutative property. Second property, associative property, A union B union C is equals to A union B union C. Then third property, identity property, A union A is equals to A. Then fourth property, A union phi is equals to A only. Understood? Then fifth property, law of universe, A union U is equals to U only. Understood? A union U is equals to U. This is all the properties of union operator. Understood? This is called the union of two sets. And example diagram, okay, Venn diagram of union operator and properties. Understood? This is all about the union operator. Understood? Then we will go for the intersection operator. Intersection operator. Understood? Intersection operator. Second one. Okay, intersection operator. The intersection operator, understood? intersection operator is denoted by reverse of u. Understood? Reverse of u. Intersection operator is denoted by the reverse of u, and defined that a and b is two non-empty sets. The union, not an union, an intersection. An intersection of two sets is denoted by the like A union B. Understood? Symbol is like reverse of U. Understood? A intersection B defined as the A intersection B. Understood? Defined as the A intersection B. Here not R. Here not R. Must and should. X belongs to A and X belongs to B. Understood? And X belongs to A and X belongs to B. Understood? Both X belongs to A and X belongs to B. Then we can say that the intersection operator. Understood? Intersection operator. Now, example if you take. Okay. Example if you take. See, example I am taking 2, 4, 6, 8. Understood? If you see our example, the intersection operator is like this. A intersection B. What is the definition? X belongs to A and X belongs to B. Here X belongs to A. What are the X? Both common elements. 2, 2, 4, 4. There is no. Okay. Both. So answer is 2, 4. Understood? A intersection B is X belongs to A and X belongs to B. The diagrammatically intersection operator is denoted as the U. This is the universal set. This is the A. This is A and this is B. Understood? The intersection operator means X belongs to A means this. What I will shade region, very important. Only this region is called the A intersection B. Understood? Now we will get idea about what is intersection, what is union. Understood? Intersection operator. And intersection operator is denoted by the reverse U, defined as that A and B in the two non-empty set, and intersection operator. I will write it. And an intersection of two sets is denoted by A intersection B, defined as the X belongs to A and X belongs to B. Understood? Example of this is 1, 2, 3 common elements. Diagrammatically union operator, intersection operator can be represented. Now properties of intersection operator also then. Understood? Properties of intersection. Intersection operator. See, properties, same properties only. A intersection B is equals to B intersection. Understood? A intersection B intersection C is equals to A intersection of B intersection C. Next, A intersection A is equals to A only. A intersection U is here changing. Understood? Then A intersection phi is phi. Understood? A intersection phi is phi. Only one thing you will learn: union operator. Remaining intersection is same one. Union what? X belongs to A and X belongs to A or X belongs to both. X is lies in both the sets. But intersection operator is X like both sets. Understood? Any one we can take union, but both we can take as the intersection. Understood? This is called the intersection of two sets. Understood? Now we will go for the difference of two sets or different operator. Difference operator. Difference operation. See, and different operation is denoted by like Difference operator is denoted by like minus. Understood? Minus. Let A and B be the understood. Let A and B be the two non-empty set and different operator and difference. And not and the difference of two sets is denoted by the A minus B. A minus B defined as the C. A minus B defined as the A minus B defined as the A minus B. X belongs to A and X does not belong to B. Understood? Difference operator means difference operator is denoted by like this. Okay, A and B be the two non-empty sets. The difference of two sets is denoted by the A minus B defined as the X. Okay, A minus B equals to X belongs to A and X does not belong to B. This is called the different operator. Understood? Now, example, we are taking different operator. Difference of operator. See, example, A is equals to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 8. Understood? B and taking are even numbers 2, 4, 6, 8, 10. Understood? A I am taking like that, B I am taking like that. Now A minus B. What is the definition? X belongs to A and X does not belong to B. If B cancel, 4 cancel, 6 cancel, 8 cancel, 10 cancel. Remaining elements you can write 1, 3, 5, 7, 9. Understood? Understood or not? This is called the A minus B. Understood? Now B minus A, you can write the B minus A. You can write the B minus A. X belongs to B and X does not belong to A and B. What is the B minus A? No, null set. Understood? There is no element. X, what are the B belongs to A? All the elements in present in A. That's why B minus A is null set. Then diagrammatically you can represent this is called the this is the square now. Okay. This is universal set. This is A. This is B. Understood? This is A. This is B. Understood? This is A. This is B. Now A minus B means this only. Only this is A minus B. Understood? If I am adding vertically or another color. Understood? This is called B minus A. Understood? This is called the A minus B. Only A. Only A. Understood? A minus. Then B minus A. There is no properties here. Understood? There is no properties of difference on set. This is called the difference on set. Understood? What is now you will get clarity about the types of sets, operation on sets. Then one more type is called complement on sets. Understood? Last final. Final complement of sets. Fourth one. Complement operation. Understood? Complement operation. What is complement operation means? First, let U be the universal set. Universal set. Let U be the universal set and capital A be the subset of U. Capital A be the subset complement of A. The complement of A is denoted by A dash. The complement of A is denoted by A dash. Defined as the A dash is equals to U minus A. Understood? A dash is equals to U minus A. Very important property. Complement of set. Complement of A is denoted by the A dash. Defined as the A dash is equals to U minus A. See, whenever you want to do this type of operation, they will give universal set. Understood? Must not should. They will give universal set. Then they will ask find the A complement, B complement, anything, any set of complement they will ask. Understood? Now, example, we will go for the A complement. Example. See, U universal set they will do natural numbers up to 10, 3, 4, 5, 6, 7, 8, 9, 10. Understood? Now, A they will give 1, 2, 3, 4, 5. Understood? They will ask find A complement. Right? A complement. Okay. Now, what is the formula? A complement is equals to U minus A. This is already previously we have discussed the difference of two sets. Means x belongs to U, x does not belong to A. So using the property U, x belongs to means I will cancel all the common elements. Remaining I can write 6, 7, 8, 9, 10. Understood? This is called the A complement. Understood? Now, diagrammatically, U complement of set can be denoted as like this. This is U, this is A. Understood? This is A. A complement is outside the set. This is A complement. All the shaded region. Understood? All the shaded region. This is A. This is the A complement. Okay. This is called A complement. A complement. A dash. Understood? This is the complement of operation. Complement operation. Then properties also there. Properties of complement. Complement operation. Okay. First property. A complement whole complement is equals to A. Then second, A union B complement is equals to A complement intersection B complement. Then third one, A intersection B whole complement is equals to A complement union B complement. Then A complement fourth one, A complement union A is equals to U. Then fifth count, A complement intersection phi. A complement U complement equals to phi complement is equals to U. Okay. Fifth one, U complement is equals to phi. Sixth one, this phi non-empty set complement is equals to U. This is all about the complement properties of complement of sets. See my dear students, in this chapter we will discuss about the what is set. Okay, set. Just 5 minutes we will briefly analyze one more time. What is set? A set is a collection of well-defined objects. Understood? Then we will go for the representation of the sets. A set can be represented by the two types. One is the set builder form and then roster form. Understood? Roster form, set builder form. Then we will go for the operation types of sets. There are how many types? 5 types of sets. One is the what empty set, finite set, infinite set, subset, equal set. Then sixth one is the universal set. Then we will go for the operation of sets. There are 4 types of operation is there. One is the union operation, second one is the intersection operation, then difference operation, and complement of operation. This is called about the set class 11 first chapter. Understood? Class 11 NCERT first chapter. Understood? First chapter, class 11 NCERT sets chapter. This is called about the introduction about the sets, and then problems we will discuss the next video. Thank you.